The transport ship shuddered as it approached the gray moon floating in the darkness of space. Jake Martinez pressed his face against the small window and watched the rocky surface grow larger. This was his first time so far from Earth, and everything felt strange and exciting at the same time. "Students, prepare for landing," announced the ship's pilot through the speakers. The voice belonged to a Zephyrian, one of the crystal-like beings that made up most of the teaching staff at the Galactic Education Consortium. Their voices always sounded like music mixed with wind chimes. Jake grabbed his backpack and looked around at his fellow students. He was the only human on this trip, surrounded by 22 aliens from different worlds across the galaxy. Some looked almost human, while others were so different that Jake had to remind himself they were all intelligent beings. Just like him, the ship landed with a soft bump on the moon's surface. Jake followed the other students through the airlock and into the research station. The air inside smelled clean but artificial, like the recycled air on space stations. The walls were metal and smooth, with soft lights running along the ceiling. "Welcome to Research Station Omega-7, said their instructor as they gathered in the main hall. Professor Veltar was a tall, thin being with blue skin and 4 arms. Each arm moved independently as he spoke, making gestures that Jake found both fascinating and confusing. "This station was built 50 years ago to study the mineral deposits on this moon," Professor Veltar continued. "But it has been empty for the past 2 years. Your assignment is simple to understand but difficult to complete." Jake pulled out his notebook and started writing. He had learned early in his studies that taking notes helped him remember important details, especially when dealing with alien technology and concepts. "You must power this entire station for 1 full cycle," the professor said. "That means 7 standard days of continuous power. The station needs energy for life support, lighting, computers, and all basic functions." A student near the front raised her hand. She was a Korthax with gray skin and large black eyes. "Professor, what power sources are available to us?" "Professor." Veltar smiled, showing teeth that were perfectly white and sharp. "That is the challenge. We have removed all conventional power sources from this station. There are no fusion reactors, no energy cells, no solar collectors, and no fuel of any kind. You must find another way." The students looked at each other with confusion and worry. Jake felt his stomach drop. This sounded impossible. How could they power an entire space station without any of the normal energy sources? "You have 7 days to solve this problem," Professor Veltar continued. "If you fail, the station's emergency power will activate, but you will fail the assignment. This test counts for 40% of your final grade." Jake wrote down the rules as fast as he could. 40% was a huge portion of his grade. He needed to pass this class to graduate from the academy. His family back on Earth had saved money for years to send him to the best engineering school in the galaxy. After Professor Veltar left, the students began talking among themselves. Jake listened as they formed groups and shared ideas. Most of the talk was about advanced theories and complex energy manipulation techniques that he barely understood. "We could try to tap into the moon's core," suggested Kexthara, a Zephyrian student whose crystalline body sparkled under the station's lights. "My people have methods for extracting thermal energy from planetary cores." "That would require drilling equipment we don't have," replied BZZ Tlak, the leader of a group of Korthax students. "Perhaps we should focus on harvesting cosmic radiation from space. Our collective consciousness could work together to build a collection array." Jake wanted to join the conversation, but he felt out of place. These aliens had grown up with technology that seemed like magic to him. Their homeworlds had energy sources and methods that Earth was just beginning to understand. What could a human contribute to such advanced thinking? "What about you, human?" asked a voice behind him. Jake turned to see a voidling floating a few inches off the ground. Voidlings were strange beings that looked like they were made of dark mist held together by silver threads. "What ideas does your species have for this challenge?" Jake felt his face grow warm. All the other students were looking at him now, waiting for his answer. "I'm not sure yet," he said quietly. I need to look around the station first and see what we have to work with. Some of the alien students laughed softly. Not mean laughter, but the kind that suggested they thought his approach was too simple or basic. Typical human thinking, said Kexthara, though not unkindly. Always wanting to examine physical objects instead of understanding the energy patterns around us. Physical examination is inefficient, added Bzz Taklak. We should focus on theoretical calculations and quantum energy manipulation. Jake nodded and tried to smile. He was used to being different, but being the only human in a group of brilliant aliens made him feel more alone than ever. I'll just explore a little bit, he said. Maybe I can find something useful. The other students went back to their discussions about advanced energy theories. Jake heard words like quantum flux extraction, dimensional power tapping, and stellar wind harvesting. These concepts were far beyond anything he had studied in his basic engineering classes on Earth. Jake decided to walk around the station by himself. The corridors were long and quiet, with doors leading to different sections. He found laboratories full of empty equipment racks, living quarters with beds that had not been used in years, and storage rooms containing various supplies and tools. As he walked, Jake thought about the challenge. The other students were all focused on creating large amounts of energy using advanced methods, but maybe that was not the right approach. Maybe the solution was simpler than everyone thought. He remembered his grandfather, who had been a mechanic on Earth. Jake, his grandfather used to say, when you have a problem, start with the basics. Understand what you really need before you try to build something fancy. Jake found a computer terminal that still worked and accessed the station's technical specifications. He studied the power requirements carefully. The station needed a steady supply of electricity, but not as much as he had first thought. The life support systems were efficient, and the lighting used low-energy bulbs. The computers and other equipment were designed to run on minimal power. As he read through the technical details, Jake began to form an idea. It was not an advanced idea like the ones his classmates were discussing. It was simple and basic, the kind of solution that his grandfather might have suggested, but would it work? And would the other students take him seriously if he proposed something so different from their complex theories? Jake closed the computer and continued exploring the station. He had 6 days left to prove that sometimes the best solutions were the simplest ones. He just hoped he was smart enough to figure out how to make it work. The other students were still talking in the main hall when Jake returned. Their voices echoed through the corridors, full of excitement and confidence. Jake listened to their plans and felt both impressed and worried. They were all so much smarter than him, with knowledge and abilities that he could barely comprehend, but maybe, just maybe, being different was not always a disadvantage. Maybe thinking like a human instead of like an advanced alien could be exactly what this challenge needed. Jake woke up on his second day at the station feeling more determined than worried. He had spent most of the night thinking about the power problem, and he had some ideas that might work. The other students were already awake and working in their groups when he entered the main hall. "Good morning, Jake," said Lisa Wong, a half-human, half-Korthax student who had been friendly to him since they arrived. Her mixed heritage made her look almost human, except for the slight gray tint to her skin and her unusually large eyes. "How did you sleep?" "Pretty well," Jake replied, grabbing a nutrition bar from the food dispenser. "What are the others working on today?" Lisa pointed to different groups around the hall. "The Zephyrians are trying to calculate how to build a cosmic energy collector using metal from the station walls. The Korthax Collective is working on some kind of bioelectrical system, using organic compounds they found in the hydroponics lab. And the Voidlings are attempting to manipulate the energy fields around the moon." Jake nodded as he ate his breakfast. All of these ideas sounded incredibly complex and required materials or abilities that might not be available. "What about you? Are you working with any of the groups?" "I'm trying to," Lisa said with a frustrated sigh. "But the Korthax Collective thinks my human side makes me too individualistic for their group mind approach. And the human part of me doesn't really understand their bioelectrical theories anyway." Jake felt sorry for Lisa, being caught between. Two different ways of thinking must be even harder than being the only human in the group. Maybe we can work together, he suggested. I have some ideas that might be worth exploring. Really? What kind of ideas? Jake looked around to make sure the other students were not listening. I want to explore more of the station first. I think there might be resources here that everyone else is overlooking, Lisa smiled. That sounds like a good plan. Mind if I come with you? I'd like that, Jake said. It would be nice to have someone to talk to while he explored. They spent the morning walking through different sections of the station. Jake showed Lisa the technical specifications he had found the day before, and they discussed the actual power requirements. Lisa was impressed by how much lower the real needs were compared to what the other students were trying to generate. They're all trying to build power sources that could run a small city, Lisa observed. But this station only needs enough electricity to keep the lights on and the air clean. Exactly, Jake agreed. My grandfather always said that the first rule of engineering is to understand the problem before you try to solve it. They continued, exploring until they found a section of the station that Jake had not seen before. The sign on the door read Recreation and Fitness Center. Jake tried the door and found it unlocked. Inside was a large room with exercise equipment that the previous researchers had used to stay healthy during their long mission. There were treadmills, exercise bikes, weight machines, and other fitness devices. Everything was old but still in good condition. This is interesting, Lisa said, looking around the room. I wonder if any of this stuff still works. Jake walked over to one of the treadmills and pressed the power button. Nothing happened, which was not surprising since the station had no power. But he noticed something else interesting. The treadmill had a small display that showed how much energy a person generated while running. Lisa, look at this, Jake said excitedly. These machines measure how much energy humans produce when they exercise. Lisa came over to examine the treadmill. That's just for tracking fitness goals, she said. The energy measurements are probably not very accurate. But they show that humans can generate electricity by running and cycling, Jake explained. What if we could capture that energy and use it to power the station? Lisa stared at him for a moment. You want to power the entire station by having people run on treadmills? Why not? Jake asked. We calculated that the station doesn't need huge amounts of power. If we could modify these machines to capture the energy instead of just wasting it as heat, we might be able to generate enough electricity. Lisa looked skeptical. That sounds like a lot of work for not very much energy. And we would have to keep running constantly to maintain power. Not just us, Jake said. All 23 students could take turns. If we organized a schedule, we could keep the station powered around the clock. I don't know, Lisa said slowly. It seems so simple compared to what everyone else is trying to do. Jake understood her doubts. The other students were working on projects that involved advanced physics and complex technology. His idea was basic and physical, more like manual labor than sophisticated engineering. Let me show you something, Jake said. He opened his notebook and showed Lisa his calculations from the night before. I estimated how much energy an average person generates while running. Then I calculated how many people would need to run at the same time to power the station's basic systems. Lisa studied the numbers carefully. Her Corthax heritage made her very good at mathematics, and she could check Jake's work quickly. Your calculations look correct, she admitted. But this would require building generators and electrical systems. From scratch. Do we have the materials for that? I think so, Jake said. There are lots of spare parts in the storage rooms. And these exercise machines already have some of the components we would need. They spent the rest of the morning examining the exercise equipment more closely. Jake found that several of the machines had small generators inside them that were used to power their displays and computers. The generators were not very powerful, but they proved that the concept could work. We would need to modify these generators to produce more electricity, Jake explained. And we would need to connect them to the station's power grid. That sounds complicated, Lisa said. It is, Jake agreed. But it's the kind of complication. I understand. This is basic electrical engineering, not quantum physics or energy manipulation. While Jake and Lisa worked in the gym, the other students were having problems with their more advanced projects. Jake could hear frustrated voices coming from the main hall as groups discovered that their theories were harder to put into practice than they had expected. The Zephyrians found that they could not collect enough cosmic energy without specialized equipment that would take weeks to build. The Korthax Collective's bioelectrical experiments were producing inconsistent results that threatened to damage the station's systems. The Voidlings discovered that the moon's thin atmosphere made it difficult for them to manipulate energy fields effectively. "Maybe your idea isn't so crazy after all," Lisa said as they listened to the complaints from the other students. "At least we know that humans can generate electricity by exercising. That's more than some of the other groups can say about their projects." Jake felt a mix of hope and nervousness. His plan might work, but he would need to convince the other students to help him. Most of them still thought that human engineering was too simple and primitive compared to their advanced alien technologies. "Do you think the others will take us seriously?" Jake asked. "I don't know," Lisa said honestly. "But if their projects keep failing, they might be willing to try something different." Jake looked around the gym and imagined it filled with alien students running on treadmills and riding exercise bikes to power the station. It was a strange image, but it might be their only chance of succeeding. "Let's start building a prototype," Jake said. "If we can prove that the concept works, maybe we can convince the others to help us," Lisa nodded. "It's worth a try. And honestly, I'd rather work on something that makes sense to me than struggle with theories I don't understand." They spent the rest of the day planning their project. Jake felt more confident than he had since arriving at the station. For the first time, he was working on a problem that matched his skills and knowledge. Now he just had to prove that sometimes the simplest solutions were the best ones. Jake spent the third day taking apart exercise equipment with tools he found in the station's maintenance room. His hands were dirty and his back ached from crawling under treadmills, but he felt more excited than tired. This was the kind of work he understood, the kind of problem-solving that made sense to him. "Hand me that wrench," he said to Lisa, who was helping him remove the generator from an exercise bike. "I think this one has a bigger output than the treadmill generators." Lisa passed him the tool and wiped sweat from her forehead. "I never thought I'd be spending my time at the galaxy's best engineering school taking apart old gym equipment." Jake smiled as he loosened another bolt. "My dad always said that the best engineers are willing to get their hands dirty. He worked in a factory on Earth, fixing machines that other people thought were too simple to bother with." "What did he think when you got accepted to the Galactic Education Consortium?" Lisa asked. "He was proud," Jake said, his voice becoming quiet. "But he also warned me not to forget that good engineering starts with understanding how things actually work, not just how they're supposed to work in theory." Jake had been thinking about his father's advice a lot over the past few days. The other students were so focused on advanced theories that they seemed to have forgotten the basic principles of engineering. They were trying to create complex solutions for a problem that might have a simple answer. "Jake, what exactly are we building here?" Lisa asked as she watched him connect wires between different generators. Jake stopped working and pointed to his notebook, which was full of diagrams and calculations. "We're building a system that connects all these small generators into one bigger system. Each generator produces a little bit of electricity when someone runs or cycles. But if we connect them all together, the total output should be enough to power the station. And you think this will actually work?" "I think it has a better chance than anything else we've tried," Jake said. "Look at what's happening with the other groups." Through the gym's windows, they could see some of the other students in the main hall. The Zephyrians were arguing among themselves, their crystalline bodies flashing with different colors as they disagreed about their cosmic energy collector. The Korthax Collective had stopped working together entirely, with individual members pursuing their own ideas instead of thinking as a group. "BZZ looks frustrated," Lisa observed, watching. The lead Korthax student paced back and forth. Yesterday he was so confident about their bioelectrical project. And look at the voidlings, Jake added, pointing to a group of the mist-like beings floating near the ceiling. They've been trying to manipulate the energy fields around the moon for 2 days, but I haven't seen any results. Lisa nodded thoughtfully. Maybe complex solutions aren't always the best solutions. That's what I'm hoping, Jake said. Let's test this generator array and see what happens. Jake had spent hours connecting the generators from 6 different exercise machines into a single system. The connections were not pretty, but they were solid and safe. He had also rigged up a simple battery system using components from the stations. Emergency lighting to store the electricity they generated. Okay, Jake said, stepping onto the first treadmill. Let's see if this works. He started running at a steady pace. The treadmill's belt moved under his feet, and he could see the generator spinning as it converted his movement into electricity. A small light on his battery system flickered and then glowed steadily. It's working, Lisa said excitedly. The light is on. Jake kept running for 5 minutes, then stopped to check the battery meter. The system had generated a small amount of electricity, but not very much. We need more people, he said, breathing hard, and we need to run longer. Let me try the exercise bike, Lisa said. She climbed onto the bike and started pedaling. Another light came on as her generator began producing electricity. They worked together for an hour, taking turns on different machines while Jake monitored the electrical output. The system was definitely generating power, but they needed to improve the efficiency and get more people involved. The concept works, Jake said as they took a break. But we need to make some modifications to increase the output. What kind of modifications? Lisa asked. Jake showed her his calculations. Each generator is only capturing about 60% of the energy we're producing. The rest is being lost as heat and friction. If we can improve the efficiency, we might be able to power the station with fewer people running. They spent the rest of the day making improvements to the system. Jake adjusted the generators to reduce friction and improve the electrical connections to minimize power loss. Lisa helped by testing each modification and recording the results. By the end of the day, they had improved the system's efficiency by almost 30%. Jake felt proud of their progress, but he also knew they still had a long way to go. Do you think we should tell the other students what we're doing? Lisa asked as they cleaned up their tools. Jake considered the question carefully. I don't think they would take us seriously yet. They're still convinced that their advanced methods are better than our simple approach. But what if they're right? What if there's something wrong with our plan that we haven't thought of? Jake understood Lisa's concerns. He had been asking himself the same questions all day. There might be problems with our plan, he admitted. But at least our problems are ones we can solve with tools and materials we have available. The other groups are trying to solve problems that might be impossible with what we have here. As if to prove his point, they heard raised voices from the main hall. Jake and Lisa looked out the window and saw Kexthara, the Zephyrian student, arguing with 2 other members of her group. Her crystalline body was flashing red and orange, which Jake had learned meant she was angry or frustrated. It sounds like they're having problems with their cosmic energy collector, Lisa said. Again, Jake added. They've been arguing about it for 2 days. The Korthax collective was also showing signs of stress. Several members were working on completely different projects, and their usual group coordination had broken down entirely. Jake could see BZZ Tclax sitting alone in a corner, his gray skin looking darker than usual. Maybe we should offer to help some of them, Lisa suggested. If their projects aren't working, they might be willing to try something different. Jake thought about this idea. We could ask if anyone wants to help us test our system. We need more people anyway, and it might be good to have their input. That's a good idea, Lisa agreed. But let's make sure our system is working well first. We don't want to invite them to help and then have everything fall apart. Jake nodded. Tomorrow, we'll do a longer test. If we can keep the system running for several hours and generate enough power to run some of the station's basic systems, then we'll know we're on the right track. As they prepared to leave the gym, Jake felt a mix of excitement and nervousness. His simple plan was starting to work, but he still had to prove that it could power the entire station. And he had to convince his alien classmates that sometimes the best engineering solutions were the ones that seemed too simple to work. "Jake," Lisa said as they walked back to their sleeping quarters, "do you really think this will work?" "I think it has to work," Jake replied. "We only have 4 days left, and none of the other projects are showing any real progress. If we can't make this work, all of us are going to fail this assignment." Lisa nodded seriously. "Then we better make sure it works," Jake agreed. Tomorrow would be the real test of whether human ingenuity could solve a problem that had stumped some of the galaxy's most advanced minds. Jake woke up on the 4th day with butterflies in his stomach. Today was the day he would find out if his treadmill generator system could really power the entire station. He had been working on improvements all week, but now it was time for the real test. "Are you ready for this?" Lisa asked as they ate breakfast together. She looked as nervous as Jake felt. "I think so," Jake said, though he was not completely sure. "We've done all the calculations and tests we can do. Now we just have to see if it works in practice." The other students in the main hall looked tired and frustrated. Jake could see that most of the alien groups were still struggling with their projects. The Zephyrians had built a partial cosmic energy collector, but it was not producing enough power to run even a single light bulb. The Korthax Collective had completely fallen apart, with individual members working on their own separate projects. "Good morning, everyone," announced Professor Valtar as he entered the main hall. "I hope you have made good progress on your projects. You have exactly 3 days remaining to complete your assignment." Jake felt his heart beat faster. 3 days was not much time, but he hoped it would be enough. "Today I will be checking on each group's progress," the professor continued. "I want to see demonstrations of your power generation methods and realistic estimates of how much energy you can produce." Jake and Lisa looked at each other. This was their chance to show that their system could work, but it was also a risk. If their demonstration failed, they would lose credibility with both the professor and the other students. "We should do it," Lisa whispered. "We've come this far." Jake nodded. "Let's set up the demonstration in the gym." They spent the morning preparing their system for the professor's visit. Jake double-checked all the electrical connections while Lisa tested each exercise machine to make sure everything was working properly. By noon, they were ready. "Professor Valtar," Jake said politely when the instructor arrived at the gym, "we would like to demonstrate our power generation system." The professor looked around the room with surprise. "You are attempting to power the station using exercise equipment?" "Yes, sir," Jake replied. "We have connected the generators from multiple machines to create a system that converts human physical energy into electrical energy." Professor Valtar's forearms moved in what Jake had learned was a gesture of skepticism. "This seems like a very primitive approach compared to the advanced methods your classmates are attempting." "It may be primitive, sir, but we believe it will work," Jake said. "Would you like us to demonstrate?" "Very well," the professor said. "Show me what you have accomplished." Jake climbed onto the first treadmill while Lisa mounted an exercise bike. They began running and cycling at a steady pace, and immediately the lights on their battery system began to glow. A small digital display showed the amount of electricity they were generating. "Interesting," Professor Valtar said, watching the display. "You are indeed producing electrical energy. But how much power can this system generate?" Jake continued running as he answered. "With 2 people, we can generate about 50 watts of continuous power. With more people taking turns, we estimate we can produce enough electricity to run the station's basic systems." "And how long can you maintain this level of output?" "We have tested for up to 2 hours continuously," Lisa said, slightly out of breath from cycling. "With a rotation schedule, we can maintain power indefinitely." Professor Valtar made notes on his electronic tablet. "This is certainly an innovative approach. But I am curious about the practical limitations. How many people would need to participate to power the entire station?" Jake had been hoping the professor would ask this question. Based on our calculations, we need 8 people exercising at any given time to meet the station's power requirements. With 23 students, we can create a schedule where everyone exercises for about 2 hours every 6 hours. That seems like a significant physical demand, the professor observed. It is, Jake agreed, but it's not unreasonable for healthy young people. And it's more practical than trying to build advanced energy systems without the proper materials. The professor continued watching them exercise for several more minutes. Jake was starting to get tired, but he forced himself to keep running at a steady pace. This demonstration had to show that their system was reliable and sustainable. Very well, Professor Veltar said finally. You may stop your demonstration. Jake and Lisa climbed off their machines, both breathing hard but smiling. Their system had worked exactly as planned. I must admit, I am impressed by your practical approach, the professor said. However, I am curious about whether your fellow students will be willing to participate in such a physically demanding solution. Jake had been worried about this problem too. We're hoping that when they see our system working, they'll understand that it's our best chance of success. We shall see, Professor Veltar said. I will return tomorrow to observe your progress. After the professor left, Jake and Lisa sat down to rest and plan their next steps. They had proven that their system could work, but now they needed to convince the other students to help them. Do you think we should ask them directly? Lisa wondered. I think we should show them what we've accomplished first, Jake said. Actions speak louder than words. That afternoon, Jake decided to run a longer test of their system. He and Lisa took turns exercising for 3 hours straight, keeping careful records of their power output. Other students began to notice the lights in the gym staying on while the rest of the station remained dark. What are you doing in there? Asked Sam Chun, a human-looking student from the Vega system. He had been working with the Zephyrians on their cosmic energy collector. We're testing our power generation system, Jake replied. Would you like to see how it works? Sam entered the gym and looked around with surprise. You're powering these lights by running on treadmills? That's right, Jake said. We've connected the exercise machines to generate electricity and store it in batteries. The system can produce enough power to run the station's basic systems. Sam stared at the glowing lights and the steady readings on Jake's electrical meters. This is actually working? It's working, Lisa confirmed. We've been testing it for several hours now. Sam shook his head in amazement. The Zephyrians have been working on their cosmic energy collector for 4 days, and they still can't power a single light bulb. But you're lighting up this entire room. Would you like to try it? Jake asked. We could use more people to help us test the system. Sam looked uncertain. I don't know. This seems so different from what everyone else is doing. What if the professor thinks it's too simple? The professor already saw our demonstration, Lisa said. He seemed impressed. Really? Sam's eyes widened. What did he say? He said our approach was innovative, Jake replied. And he acknowledged that it works. Double quote. Sam thought about this for a moment. The Zephyrians are getting frustrated with their project. Maybe I should mention your system to them. That would be great, Jake said. We need all the help we can get. Within an hour, several other students had come to the gym to see Jake's system in action. Most of them were impressed by the steady power output and the practical nature of the solution. A few even volunteered to help with testing. This is amazing, said Amy Rodriguez, a student from the Centauri colonies. It's so simple that it actually makes sense. But can it really power the entire station? Asked Kexthara, the Zephyrian student. Her crystalline body was flashing with colors that Jake had learned meant curiosity and interest. We think so, Jake said. But we need more people to help us test it properly. I will help, Kexthara said. Our cosmic energy collector is not working as planned. Perhaps it is time to try a different approach. By the end of the day, Jake. And Lisa had 8 volunteers willing to help test their system. For the first time since arriving at the station, Jake felt truly confident that they might actually succeed in powering the entire facility. Tomorrow we'll do a full test, Jake told the group. "If we can keep the station running for 24 hours, we'll know our system can work." The other students nodded with determination. They had all seen their own projects fail, and they were ready to try something that actually produced results. Jake went to bed that night feeling hopeful. His simple human solution had brought together students from across the galaxy, all working toward the same goal. Maybe being different was not a disadvantage after all. Jake woke up on the 5th day to the sound of voices and movement throughout the station. When he entered the main hall, he saw something that made him smile. Students from all different species were organizing themselves into groups, discussing schedules and taking turns on the exercise equipment. "Good morning, Jake," called out BZZT Clack, the Korthax student who had been leading his own failed project just days before. "I have calculated an optimal rotation schedule for our power generation system. Would you like to review it?" Jake felt amazed by how much things had changed. 2 days ago, most of these students had been dismissing his ideas as too simple. Now, they were working together to make his system succeed. "I'd be happy to look at your schedule," Jake said, taking the tablet that BZZT Clack offered him. The calculations were detailed and precise, showing exactly how many people needed to exercise at each time to maintain steady power to the station. "This looks excellent," Jake said after studying the numbers. "You've even included backup people in case someone gets tired or needs a break." "The Korthax are very good at organizational planning," BZZ Clack replied with what Jake had learned. Was a Korthax smile. "It feels good to use our skills on a project that actually works." Lisa joined them, looking excited. "Jake, you need to see what's happening in the gym. Kexthara and her Zephyrian friends have made some improvements to the generators." Jake followed Lisa to the gym, where he found the crystalline Zephyrian students working on the exercise equipment. Kexthara's body was glowing with soft blue light as she adjusted something inside one of the treadmills. "Jake, we have increased the efficiency of your generators by 15%, Kexthara announced proudly. "We used our understanding of crystal resonance to reduce friction in the mechanical systems." "That's wonderful," Jake said, genuinely impressed. "How did you do it?" Kexthara showed him the modifications she had made. "We grew small crystals that can be placed at the friction points in the generators. The crystals absorb vibrations and convert them into additional electrical energy instead of heat." Jake examined the modifications carefully. The Zephyrian improvements were elegant and effective, using advanced alien technology to enhance his basic human design. "This is brilliant," he said. "You've made the system much more efficient." "We are happy to contribute," Kexthara replied. "Your idea gave us a foundation to build upon." Sometimes the best solutions combine simple concepts with advanced refinements. As the day progressed, Jake watched in amazement as students from every species found ways to contribute to the project. The Voidlings used their energy manipulation abilities to optimize the power flow through the electrical systems. A group of students from the Andorian colonies redesigned the exercise schedule to account for the different physical capabilities of various species. Even Sam Chun, who had been skeptical just a day before, was now enthusiastically helping to test different machines and record power output data. "I can't believe how well this is working," Sam said as he finished his turn on an exercise bike. "Yesterday I thought we were all going to fail this assignment. Now it looks like we might actually succeed." "We're definitely going to succeed," Jake said confidently. "Look at the power readings." Jake pointed to the main display that showed the station's power consumption and production. For the first time since they had arrived, the station was running on student-generated electricity instead of emergency backup power. All the lights were on, the air recycling systems were running normally, and even the computers were functioning perfectly. "The best part is that we're generating more power than we need," Lisa added. "We have enough extra electricity to charge backup batteries in case someone needs to take a longer break." Professor Veltar arrived in the afternoon with several other instructors to observe their final demonstration. Jake felt nervous as the group of alien professors entered the gym and main hall, but he was also proud of what they had accomplished. "Students," Professor Veltar announced, Please demonstrate your power generation system for the evaluation committee. Jake looked around at his fellow students. They had practiced this demonstration several times, and everyone knew their role. Okay, everyone, Jake said, let's show them what we can do. The students took their positions on the exercise equipment. Jake climbed onto his usual treadmill while Lisa mounted her exercise bike. Kexthara and 2 other Zephyrians took positions on machines that they had modified with their crystal technology. Clack and several Korthax students began cycling. On other bikes, following the precise schedule they had calculated, within minutes, the entire station was running on student power. The lights blazed brightly, computers hummed with activity, and the air recycling systems worked perfectly. The power displays showed steady, reliable electricity production that exceeded the station's needs. Impressive, said one of the instructors, a tall being with silver skin and multiple eyes. How long can you maintain this level of power production? We have been running the system continuously for 18 hours, Bzz Teklak replied while continuing to pedal. Our calculations show that we can maintain power indefinitely with our current rotation schedule. And what happens if some students become tired or unable to continue? We have backup people scheduled at all times, Kexthara answered, her crystal body glowing as she ran. We also have battery storage that can provide power for up to 6 hours if needed. The instructors spent the next hour testing different aspects of the system. They asked students to stop exercising to see how quickly the backup batteries activated. They requested changes to the power load to test the system's flexibility. They even had some students take breaks to see if the remaining people could maintain adequate power levels. Every test showed that Jake's simple concept, enhanced by alien technology and organization, was robust and reliable. This is quite remarkable, admitted Professor Veltar. You have successfully powered the entire station using only the physical energy of the students themselves. The concept was Jake's idea, Lisa said proudly. He figured out that we were trying to solve the wrong problem. Instead of generating huge amounts of power, we just needed to generate enough power consistently. And the rest of us found ways to make his idea work better, added Kexthara. My people improved the efficiency, the Korthax optimized the organization, and everyone contributed their physical energy. Professor Veltar nodded approvingly. This demonstrates excellent collaborative engineering. You have combined practical problem-solving with advanced technical knowledge to create an effective solution. The lead instructor, an ancient crystalline being whose name Jake could not pronounce, stepped forward. In 60 years of teaching at this academy, I have rarely seen such an elegant solution to an engineering challenge. You have proven that the most sophisticated technology is not always the best technology. Jake felt his cheeks grow warm with pride and embarrassment. Thank you, sir, but this really was a team effort. Everyone contributed something important. Indeed, the ancient instructor agreed. But the foundation was your insight that complex. Problems sometimes have simple solutions. This is a lesson that many advanced civilizations have forgotten. As the instructors prepared to leave, Professor Veltar made an announcement. Students, you have not only passed this assignment, you have exceeded all expectations. Your collaborative approach and practical thinking will be studied as an example for future classes. After the instructors left, the students continued running their power system, but now the mood was celebratory instead of anxious. They had solved an impossible problem by working together and thinking creatively. Jake, said Sam Chun as they finished their shifts, I owe you an apology. When I first saw your treadmill idea, I thought it was too simple to work. I was wrong. We're all wrong, admitted Bzz Teklak. We were so focused on complex solutions that we forgot about practical ones. Jake looked around at his fellow students, aliens from worlds across the galaxy who had become his friends and collaborators. I learned something too, he said. My simple idea was just the beginning. It took all of our different skills and knowledge to make it really work. That's the best kind of engineering, Lisa said with a smile. When everyone contributes their strengths to solve a problem together. As Jake prepared for bed that night, he thought about his grandfather's advice about starting with the basics. His grandfather had been right, but Jake had learned something more. The best solutions came when you combined basic practical thinking with advanced knowledge and collaborative teamwork. Jake had come to the academy feeling like an outsider, the only human among brilliant alien students. Now he understood that being different was not a disadvantage. It meant he could contribute something unique and valuable to any team. Sometimes the galaxy needed human ingenuity just as much as it needed alien technology.